Welcome to Cloud on Air, live webinars from Google Cloud. We are hosting webinars every Tuesday. I'm Shubhika Taneja, and I'm a part of the Google Cloud networking team. I have with me Inez Enwith, who is a product management lead for several Google Cloud networking products. In this talk today, we'll be talking about how GCP does networking and what are some of our differentiators. So let's get started. You might be wondering, why am I opening a talk on the Google Cloud network with this slide? Well, it's the focus on the infrastructure that has led Google to scale the way we have. And it's very well depicted by these 7 Google applications that I'm sure all of you are familiar with. Google Search, Chrome, Android, YouTube, Gmail, Google Play, and Maps. Each of these products are serving 1 billion users. One of the core fundamental differentiators that acts as the backbone for all these Google apps is our network, which is what we'll be discussing in this talk today. And our goal at Google Cloud has been to give you access to this same backbone that powers our billion users' apps. So you can delight your customers by using networking services that are reliable, secure, and at scale. When you think about GCP networking, there are 2 elements to think about. One is the Google infrastructure under the hood, and second is the networking services that you can buy and consume. So let's first start by discussing the first element that I just mentioned, the Google infrastructure under the hood. And this is something you get by default when you move to GCP. Over the past 3 years, we have spent over $30 billion, and a big portion of this investment has gone towards continuing to build and enhance the world's largest private software-defined network. This Google network carries 25 to 40% of the global internet user traffic. In fact, most people start by typing www.google.com to test their network, and that shows the amount of trust placed in our network. Now let's look at some of the specifics around our global presence, which is, again, very important to our customers. Google Cloud Platform has 18 regions that are live today, and we will continue to expand by opening more regions in the next several months. Switzerland, Japan, Indonesia are some of the upcoming data center regions. Also, we have 134 POPs, or points of presence. These are the points where the traffic is exchanged between the public internet and the Google Cloud network. 9 years ago, Google became the first major non-telco to build an undersea cable. And till date, we have invested in 13 subsea cable investments, including 2 private subsea cables which were announced last year. The sprawl and crawl of this infrastructure enables several tangible differentiators for the GCP network. One of them is the premium networking tier. When you think about running workloads in the cloud, the first thing that you always think about is compute. And storage is most likely the second thing, because storage and compute are fundamental elements to running any computational task. But just like Newton gave us 3 laws of motion, not 2, there is a third equally important piece that you need to think about, and that's your network. Network is what carries the data between your user or customer to your applications running in the cloud and back. So it's pivotal in determining the customer experience. The GCP network enables us to offer you a unique combination of speed and reliability. Most cloud providers use what's called the hot potato routing, which you see on the bottom of this slide. When you're sending out traffic from their infrastructure, most cloud providers offload it to the public internet as soon as possible. It's like a hot potato. They want it off their hands. On the other hand, we use cold potato routing. We keep that traffic on the Google's private network as long as possible and exit it to the public internet at a location nearest to the end user, usually in the same city or town. And that enables us to offer better reliability, better performance, and more security. So in a nutshell, a better customer experience. So with this, let me quickly jump to a demo and show you how to enable these tiers between standard and premium tier. So if you look at the Google Cloud Console, let's quickly go and create a new instance. We'll keep all the default options. We'll call this instance Cloud on Air. Let's hit create. And while that is getting created, let me show you where you can find these tiering options. So if you go under networking on the console, you'll see this networking service tiers option. If you click on that, you'll see a default here, which is set to standard right now. This is a default that applies to your project. So any instances you create in this project, by default, they will be created in the standard networking tier, which is the hot potato routing that we talked about earlier. So this is ideal for your dev test environments. You don't care about having a super high network performance for that. You can keep your costs minimal, and you can use the standard networking tier. And now when you are ready to move to production, for instance, you can go and change the tier here. You can actually click Change Tier, hit Premium. And this will make sure that any future instances that you create in this project, they will all be created with the Premium tier option. So now let's go back and look at our VM that we just created. Cloud on Air is right here. And if you click on this, since this was created with the standard tier option, if you look under the network interfaces, you'll see right here the network tier is standard, which was the default earlier on. And if you want to go and change that, you can do that very easily. You can just click Edit, go to the network interfaces option right here, and change the networking tier from standard to premium. And that's all. So that's how you can easily switch between the two tiers. So with that, let's come back to these slides and look at the performance. Cidex is an internet performance monitoring and optimizations tools company, which is now a part of Citrix, did some preliminary performance measurements for both tiers. As expected, premium tier delivers higher throughput and lower latency. From this graph, you can see that the premium tier throughput is about 1.7x the standard tier throughput. So to summarize, blue on the bottom is what you get from standard tier and most other cloud service providers, whereas green on the top is what you get only from the premium tier. Now let's look beyond the infrastructure innovations and talk about some of the algorithm innovations that have moved the needle in delivering higher network performance. At Google, our long-term goal has been to make the internet faster. And over the years, we have made changes to make TCP faster. We have developed the Chrome web browser. Quick and BBR are two other networking-related innovations in this direction that have made internet faster. And let's take a look at both. So to understand BBR, let's first think about how TCP was designed to work fundamentally. TCP tries to strike a balance between being fast and balancing the use of the available pipe between multiple users. It is the congestion control algorithm running inside every computer, tablet, or any other device hooked to the network that decides how fast to send the data. Historically, internet largely has used loss-based congestion control, where packet loss is used as an indicator to slow down the data transmission. This results in the non-optimum use of network bandwidth in today's diverse networks, and that leads to poor network performance. Now let's look at how BBR does this differently. BBR stands for bottleneck bandwidth and round-trip propagation time. It is a new congestion control algorithm developed at Google, which is designed to respond to the actual congestion instead of packet loss. BBR models the network to send as fast as the available bandwidth, and it is 2,700 times faster than previous TCPs on a 10 gig 100 millisecond link with 1% packet loss. BBR also powers Google.com, YouTube, and apps running on the Google Cloud services. Now, if you look at the BBR benefits to Google Cloud customers, there are two ways to look at it. Benefits to the cloud administrators. When GCP customers are talking to GCP services, such as cloud storage or cloud spanner, the traffic is sent to the application using BBR. And this helps in speedier access to your data. The second angle is benefits to users using apps running in GCP. These are the end users running apps in GCP. When GCP customers use Google Cloud Load Balancing or CDN to serve and load balance traffic for BBR, for their websites, the content is sent to the user's browsers using BBR. And again, this helps in loading the web pages faster. So now let's talk about Quick, which is the second thing that we wanted to discuss in this section. For 5 years now, Google has been using Quick. It's a UDP-based encrypted transport protocol optimized for HTTPS to deliver traffic for our products from Google Web Search to YouTube to this very cloud on air. If you're watching this in Chrome, you are most probably using Quick right now. If your service is sensitive to latency, Quick will make it faster because of the way it establishes connections. When a web client uses TCP and TLS, it requires 2 to 3 round trips with a server to establish a secure connection before the browser can even send a request. With Quick, if a client has talked to a given server before, it can start sending data without any round trips. So your web pages will load a lot faster. Now, specifically for our cloud customers, we have been rolling out Andromeda updates to keep innovating and boosting performance. Andromeda is our network virtualization. You may think of it as one of the key pillars of our SDN stack. As you can see here, we have been able to achieve 780% improvement in latency since launch for the GCP customers. You can't build a world-class distributed computing infrastructure without world-class networking infrastructure. Google is constantly innovating in the networking space. And on this cloud on air, we don't have the time to go into the details for every innovation. So here is a slide to wrap up this section, showing a time shot of some of the major innovations in the past, which are the fundamentals of our software-defined network. We took the software-defined approach early on, and in almost everything we do. Maglev is our software load balancer that routes all incoming traffic to correct backends. B4 is our WAN network built using SDN principles. Jupyter is our software-defined data center networking. And Andromeda, as we just discussed, is our network virtualization technology. With that, let me bring on Ines to talk more about our networking product portfolio.
Good morning. So when, in general, when you're thinking about the networking products that you are facing as a customer, and the offering that we have in Google is a very broad portfolio. To conceptually segment, we can conceptually segment into 2 buckets. One is build your cloud, which will include all the connectivity options as an interconnect, VPN, peering. So it allows you to construct your cloud connecting to your own data centers, on-prem or other public clouds, and it also to build your topology, your private topology on the cloud. And of course, a fundamental part of it is VPC. The other bucket is deliver your applications, which includes load balancer, DNS, content delivery, network tiers, Cloud Armor. We could talk about this for hours, but since only have a finite amount of time, we will cover some of the areas where Google has taken a very unique approach to build those products to solve very concrete customer problems. So first, let's understand what VPC is. So the first thing you need when you come to cloud is your own piece on cloud made private for you. So a VPC is your own logically isolated and secure piece of Google Cloud. It closely resembles a traditional network, something that you could operate in your own data center, but with the benefits of scalable and elastic infrastructure. So as you can see, we are having a global VPC that span across all the regions that allows you to build a private single network globally across all your deployments. So by the numbers, you can have 18 regions where you deploy your workloads with a single VPC that connects them privately just by coming to Google Cloud Platform. So let's see what makes our VPC global and different. So GCP takes a more intuitive approach to VPC peering by offering a concept of shared VPC, which is illustrated in this visual. Unlike AWS and Azure, GCP does not require that its project has its own network. Cloud architects can create a single global or regional production shared VPC network within GCP and then creates production projects to isolate and organize their resources and their teams. They can map their organizations appropriately. Essentially, what GCP is offering customers is a shared VPC that models out of the box connectivity across those deployments and those teams without the hassle of setting things up, leveraging a shared VPC that allows cloud architects to centralize shared services like DNS, directory services, auditing, monitoring, security, and more. It allows also for a single connectivity point into GCP. Following the slide here, you have on the left a traditional VPC in which you as a customer will come, you will deploy in US West, US Central, Asia East, and then you will need to create a different VPC in each of those regions. Then you will need to go and create connectivity to privately connect those separated regional VPCs. In addition, now you need to connect your data centers to each of those regions. You can see that this traditional approach to VPC, it creates a lot of overhead in terms of connectivity, setting things up to provide the connectivity that you need for your global deployments and across all your teams. Now, let's look at the approach that Google Cloud is taking for Google VPC. In contrast, you can see that for the same deployments in US West, US Central, and Asia East, you just configure a single VPC. In doing so, you get private connectivity through Google Backbone. You utilize that connectivity for privately connecting the deployments and the workloads across your regions without having to get any external private connectivity. And in addition to all that, you can just connect from your data center through a single point. In this case, it is in GCP US West. When you connect to that, to the POP associated to a US West region, then you automatically get access to the private Google network that then can access, using the Google network, all the resources and deployments globally. So when we're looking at what is the benefits of shared global VPC, it really provides a consistent operational model. Network security is enhanced because the traffic never traverses the public internet, as we saw in the picture before. The private connectivity across the regions is provided automatically by setting up your global VPC. You have a resource hierarchy, which is an organization, a folder, and projects in which you map your teams, your deployments, your organization. And by having a shared VPC, besides being global, it also provides the connectivity for all that resource hierarchy that represents your teams and your different DevOps operating deployments for your business. You can have a common security team that then apply the network security policies centrally, and then it will automatically apply across all the teams. So then you can have a consistent security model that is easier to set up, but it's also easier to monitor and understand deviations from the desired behavior. And then finally, you want to contain the cost, so you don't want a network administrator or a CISO for each of the projects. So having this centralized model, it models very easily your current model in which a single centralized administrator can really take care of the networking and security constructs for your organization and all your teams in a single place. So all in all, we're providing a consistent operational model that takes enterprise model into cloud. You don't care about managing security, you just want to be quick, keeps people managed to their core competence without having to worry about setting up networking and security, and just focusing on doing their job. So let's take a look now on how do you actually connect your on-prem data center deployment to Google Cloud. So there are several options for Google Cloud hybrid connectivity. There are two flavors of Cloud Interconnect. We have dedicated interconnect, which offers 10 gig dedicated links to connect to Google Cloud with industry-leading SLAs. You have 99.99% uptime guaranteed. Partner Interconnect, on the other hand, it provides an ecosystem of partners so that you can actually have more flexibility on connecting to Google Cloud in more places. It also provides the capability of having flexible bandwidth, so you don't really need to have a dedicated 10 gig, but you can have sub bandwidth pieces of that 10 gig pipe. We are offering as well Cloud VPN, which it is an IPsec encrypted tunnel across the internet, and then that provides bandwidth up to around 3 gigabit per second, and then you can set up multiple tunnels and ECMP your traffic. And finally, we offer peering, which it allows you as a customer to connect directly, publicly to Google ASN by either directly peering with us, with Google, or picking a partner that you peer with, and that partner will peer over BGP with us. Finally, we have over 72 dedicated locations around the world where you can connect directly to cloud using 10 gig pipelines. With up to 8 connections per interconnect, you have 80 gigabit per second at your fingertips to configure a dedicated pipeline in which you can load balance the traffic over 8 10 gig pipelines to connect to Google Cloud. And we, of course, as well have a very broad partner ecosystem. We have several partners so that if you have variable bandwidth requirements or prefer working with a partner, you can connect to GCP using the partner interconnect. So, go ahead. Yeah, I'm going to hand over to Subika, who's going to now talk about the other piece of the portfolio, which is how we deliver the applications on top of your private cloud.
Thanks, Ines. Google offers its Layer 4 and Layer 7 load balancing with a single construct priced based on the number of forwarding rules configured. This can simplify management and billing processes for the users. Google's HTTPS load balancer is the only one to support QUIC, which we had discussed earlier, and that is especially good for customers with low bandwidth connections. Now let's dig a little bit deeper to understand an important differentiator of the global load balancer that GCP offers. Load balancers in other cloud providers are usually regional, and what that means is that per region you need a virtual IP for your load balancer, and then you have your backends in those regions as well. Now regions are silos, so the load balancer in one region cannot leverage the capacity of the load balancer in another region. At Google, we tried to rethink how global load balancing is done so that you are not dependent on the DNS load balancer to do so. It doesn't matter where you put your application instances, you get a single front-end WIP or a virtual IP, in which case you get full global capacity cross-region failovers across your regions. And the other cool thing about our load balancer is that it's closely tied up to the autoscaler. As your traffic grows, it scales up your backend instances and vice versa when your traffic goes down. So Google Cloud Load Balancing reacts instantaneously to changes in users, traffic, network, backend health, and other related conditions. Since we are talking about application delivery, securing your internet-facing apps is another important piece to that. Now this graph shows DDoS attacks on Google's own services, such as YouTube, Gmail, and Google Search. As you can see, the scale of these attacks is growing exponentially. In fact, we asked our DDoS team, what does absorbing a huge DDoS attack feel like? And this is what they had to say. It's like watching, it requires the bandwidth needed to watch 500,000 YouTube videos at the same time. And remember, in HD. So to defend against this threat, we deploy edge infrastructure and security systems to mitigate attacks targeting our services. And this same infrastructure underpins Google Cloud. With Google HTTPS load balancing, the first GCP service to support Cloud Armor, you get built-in defense against infrastructure DDoS attacks. That means no additional configuration other than to configure load balancing is required. So that brings us to the end of our talk, and please stay tuned for live Q&A. We will be back in less than a minute. Welcome back. So it looks like we have some questions from the audience. The first question, how are the networking functions realized in the network? Ines, do you want to go ahead?
Sure. Yeah, Google takes a very unique approach of implementing networking functions. We philosophically and in reality materialize all the networking functions as programmable functions in our network. So we distribute the functions across regular, purpose hosts where we're actually hosting compute capabilities, so that might be dedicated specifically for networking. And then in doing so, we're able to first really provide the functions in an scalable manner as closely to the compute functions as possible, and being able to horizontally scale without having any bottleneck. So this really allows us to scale and to provide no bottlenecks in our network due to the fact that traffic may need to go through appliances. Everything really, it's implemented in highly scalable or horizontally scalable architecture.
All right, so the second question we have is on VPC. That's your area. How do I deploy regional applications with global VPC?
This is an interesting question because Google Cloud has a global VPC. I think sometimes there is a misconception that it doesn't support regional VPC. So you can think of global VPC as a superset of what you can do with a regional VPC. So the fact that it is global, it just allows you optionally to deploy your workloads globally and privately connect them. But if you want to regionally have your deployments constrained to a single region, you totally can do so just by deploying your compute workloads, your storage bucket, your BigQuery datasets in a specific region. And then your VPC might be created global, but it provides a constrained regional connectivity. You have as well things like core policies to restrict where your workloads can be deployed, so that if you actually care about restrictions because of policy, regulatory reasons, you have actually constructs to express that in the use of global VPC and restrict to a specific region.
So the third question is around premium standard tier GA. So we have always had premium tier. Standard tier is another option that we offer now. It's in public beta and it will be going GA shortly. Another question on VPC. With a shared global VPC, how do I control communication between projects?
Yeah, this relates to how do I actually map my deployments, my teams, to that global shared VPC, and how do I control what is the communication channels across those deployments. So we offer a very flexible model on grouping deployments that can be mapped either to a project, or it could be mapped to a sub-project set of deployments. And then you can either associate tags or you can actually group them with their service accounts. Once you have grouped those applications, then you can actually use those groups either based on tags or based on the service account in the construct of your firewall. So when you construct your firewall, you can express it in a way in which it is from a specific tag A, your service account A, to a specific tag B, service account B. And then in that way, you really can define very granularly what are the communication policies of those workloads. That is really the most common setup that our customers are using for controlling that communication.
And the last question is a very interesting one as well that we talk about a lot. How do I access Google services such as cloud storage and BigQuery?
Yeah, so we, as Google Cloud Platform has one of the most powerful offerings in terms of managed services, and definitely, cloud storage like GCS or BigQuery are big product stars in our portfolio. Our customers are accessing those services with a very high throughput bandwidth. We deploy everything as part of the VPC, meaning that it is all private communication when you're accessing your Google Cloud Storage bucket or your BigQuery data set. It is all done privately from your either VM instances in cloud or from on-prem if you are communicating through private connectivity to the VPC. And we're also doing it in a very scalable manner. We provide as well a scalable architecture so that you can go to 100 of gigabit per second for accessing these services. And this is really one of our key strengths of VPC, is really the capability of accessing with high throughput our Google managed services. So I think that's it for now. Thank you so much for attending, and stay tuned for the next session.